All right, today we're going to try to finish up the chapter, but I doubt if we get that far because symmetry itself is its own topic we have to discuss. And then we'll look at transformations. Section 4 deals with symmetry. We're going to look at that. We're going to look at odd, even functions, and we're going to look at reflections. And if we have time, we'll jump into transformations. If not, then we'll finish it on Thursday. What does symmetry mean? If something is symmetric, what does that mean? Yes. It's a mirror image. It's a mirror image. It is the same. Grab a sheet. And that's why we also use the word reflection. When we look at, with respect to our XY axis, we have three types of symmetries or reflections we can look at. The first one we're going to look at is symmetric about the y-axis. Then we'll look at symmetric about the x-axis. And then we'll look at symmetric about the origin. And then we'll talk about what defines an odd or even function. And then we'll look at reflections and how you can just look at the equation and tell me if there's going to be a reflection. Reflections only occur across the y-axis or the x-axis. Grab a sheet, please. I'll use the word about. So I'll say symmetric about the y-axis. That just means around that axis. If something is symmetric about the y-axis, these points here. Yeah. 1, 2, 3, 4, 5. -1, -2, -3, -4, -5, 1, 2. Put down so. So if I gave you this point here, what is the location of that point? Three, 1. What's the mirror image across the y-axis? What's that location? -3, 1. If I had this point here, that location is 1, 4. What is its symmetric point about the y-axis? -1, 4. Very good. So what's happening? How do we test to see if something is symmetric about the y-axis? Well, yeah, you say the horizontal. Yeah, I never thought about it. Yes, you can think of that. But more so, that's why I said let's look at the location of these points. what's the only difference about these points? What's positive, negative? The x values. So to if you have the same y values, but the x values are the same number, with opposite signs. So something is symmetric about the y-axis if you have the same y values, but the x values are the same number, but opposite signs. So the only thing that changes is the x value. If it's symmetric about the x-axis, find me the points symmetric about the x-axis of those two locations. So what's the first location of this one? 2, 3. So what is its reflection? Or it's got to be across the x-axis. It's got to be, so it's got to be straight down. 2, -3, yes. And this other point, what is its location? What is its point about the x-axis? 4, 2. So if you're changing, these are actually, what we have here, we have reflections. This is a reflection about the y-axis. Symmetric. So this one mirrors with this one. The only thing it changes, because the y's stay the same, the only thing it does is change the x value. This one, the x's stay the same, and the y's change. So if you have the same x values, but the y values are the same number, with opposite signs. So whatever axis you're symmetric about, that if it's about the x's stay the same. If it's about the y-axis, the y's stay the same. So we're going from xy to x negative y. The only thing changes are the y values. Now, if we do them both at the same time, about the x and the y, we have something that is symmetric about the origin. In this case, it includes both the x and y axis. So find me the mirror image points of these 3 points symmetric about the origin. Let's start with this one. What is its location? Very good. So if you flip it about the origin, bless you, what would it be? Remember I told you, it's you do both the x and y flip. So if you flip it across the x-axis, what's it going to be? It'll be -3, -1. Then you flip it across the y-axis, it's going to be -3, -1. Both signs change, yeah. Here, both signs change. Because you're flipping about the x and the y-axis. So this one is 4, 2. Its mirror image across the origin would be -4, -2. And the third one is 1, 3. So it's going to be -1, -3. So how do we determine if it's symmetric about the x, y, or origin? Let's see. To test symmetry. If it's symmetric about the y-axis, that means x changes from positive to negative, and the y stays the same. So here's an example. Y equals x squared. The way you test it, so you pick two, you pick one number. Let's pick two. You take one number is positive, one number is negative. Plug it into the function. So we have 2 squared equals 4. Negative 2 squared equals 4. Since the x values are the same number, opposite signs, and the same y values, this is symmetric about the y-axis. We also call that an even function. An even function, if you ask to find an even function, you're looking to which functions are symmetric across the y-axis. And this is the way you test it. Plug in the same number but different signs and see if you get the same answer. The x-axis. Y changes from positive to negative. For the same x value. An example of this one would be just the opposite of that. What would the first, let's go back to this. What would the graph of the first example be? Parabola. It's a U with center at the origin. So if I pick the value of 2, it equals 4. If I pick a value of negative 2, it also equals 4. So there you have an example of symmetric about the y-axis, or an even function. What do you think this graph looks like? Because it looks a lot like this one, but the other number squared. This one is a hyperbola. If I had the number 4 inside there, if x equals 4, if x equals 4, it's got to be the same. What number can I put inside y to make it equal 4? 2 or negative 2? And this is, you can't call this one even or odd or anything because it's not a function. Why is it not a function? It fails the vertical line test. Vertical line test says if you can draw a vertical line and cross the graph at 2 points, then it's not a function. Then about the origin. When x changes from positive to negative x, then y changes from positive to negative, or changes signs, basically. I'll give you two examples here. Again, it helps if we plug in values. So if, in the first one, if I plugged in 2, what does y equal? 2. If x equals 2, then y equals 2. If I put -2 in there, then y is -2. So that's across the origin. It's through both of them. Same thing here. If I put 2, 2 cubed is what? 8. It's 2 times 2 times 2. That's what the cube means. 2 times 2 times 2. How about if I put -2 in there? What's that going to equal? -8. Because you have -2 times -2 times -2. So that's mathematically how you would check it. Just take your function, plug in the same number but different signs, and see what happens to the answer. One of four things can happen. It could either be this one, it could be this one, it could be this one, or it's none of them. So let's look at the graphs of these. What does the graph of the first one look like? It's a linear function, so what does it look like? It's a diagonal line. So when x is 2, y is 2. When x is -2, y is -2. How about this one? Again, I asked you guys 2 weeks ago to memorize library functions. It's going to make the next section a lot easier if you know these. Very good. Like that, exactly. Very good. If x equals 2, then y equals 8. If x is -2, then y equals -8. Let's go down. It's across the origin. if it's symmetric about the origin, we call that an odd function. Now, the reason they're called odd and even functions is just because of that. They're It has to do with the exponents. Remember, even functions are symmetric about the y-axis. Odd functions are symmetric about the origin. What if I gave you that function? Is it symmetric about the x, y origin, or neither? Why do you say that? Excellent. Exactly why. So give me a value for x. Let's say 2 and -2. If I put 2 in there, what is that? What does y equal? 3. If I put -2 in there, what does y equal? 3. It's symmetric about the y-axis. It is a horizontal line at 3. So therefore, since it's a horizontal line and it's symmetric about the y-axis, it's an even function. Normally at this point, what I do is I give 9 examples, and we try to look for patterns. So we'll work on these together. And for all of these examples, we're going to use the same number, x equals 2 or -2. Remember, all you do is pick a number and test it. So when x is 2, we got 2 squared plus 2. When x is -2, we got -2 squared plus 2. Two squared is 4. 4 plus 2 is 6. -2 squared is also 4. 4 plus 2 is 6. So these are points. The x was 2 and the y is 6. The x is -2, the y is 6. So is that an odd, even, or neither function? Yes, it's even. It's even because the y's stay the same. It's symmetric about the y-axis. So this is even. The other one, we have when x is 2, we have 2 plus 2. When x is -2, we have -2 plus 2 equals 4 and 0. So we have the point at 2, 4 and the point at -2, 0. Odd, even, or neither? Yeah, neither. Because the y's are different, so it doesn't matter what the x's are. Let's look at these two. So we have 2 to the third plus 2 squared, -2 to the third, -2 squared. So 2 cubed, 2 times 2 is 4 times 2 is 8. 2 squared is 4. 8 plus 4 is 12. So that point is 212. -2 cubed is -2, -2, -2 makes it -8. -2 squared, -2 times -2 is +4. -8 plus 4 is -4. So we got -2, -4. The y values are different, so it's neither. The next one, 2 cubed plus 2, -2 cubed plus -2. Two cubed is 8 plus 2 is 10. So that point on the graph is 210. -2 cubed is -8. A positive and negative is a -2. They're both negatives. 8 plus 2 is 10. So this one is -2, -10. So what is this one? Odd, even, or neither? This is odd because it's symmetric about the origin. The x's and the y's change signs. Let's look at these two. Of 2 cubed plus 2 plus 2. Negative 2 cubed. Negative 2 plus 2. Two cubed is 8 plus 2 plus 2. So 8 plus 2 is 10 plus 2 is 12. So this point is 212. Negative 2 cubed is negative 8. A positive and a negative is a negative 2, then a plus 2. Plus 2 minus 2 cancels. We have negative 8. So we have negative 2, negative 8. So what's that one? Odd, even, or neither? Neither, because the y's are different. 2 to the 4th, 2 squared plus 2. Negative 2 to the 4th, negative 2 squared plus 2. Two to the 4th. 2 times 2 times 2 times 2 is 16. 2 squared is 4. 16 plus 4 is 20. Plus 2 is 22. So that point is 222. Negative 2 to the 4th. What is that going to be? Negative 2 times negative 2 times negative 2 times negative 2. It'll be positive 16. Negative 2 times negative 2 is 4. Times negative 2 is negative 8. Times negative 2 is positive 16. You have an even number of negatives. Plus negative 2 squared. Negative 2 times negative 2 is positive 4. 16 plus 4 is 20, plus 2 is 22. And the last two are the ones that we did originally. Sorry. Good point. Odd, even, or neither. Even. Very good. Because the y values are the same. Same sign, same numbers. F of x equals x. So when x is 2, we get that. When x is negative 2, we get that. And there's that point. Odd, even, or neither. Very good. It's odd. Why is it odd? Because both X's and Y's are the same numbers, but they change signs. The X, same number, change signs. The Y is same number, change signs. Two squared and -2, -2 squared. 2 squared is 4. -2 times -2 is also 4. So 2, 4, -2, 4. Odd, even, neither. Even, yes. Because the X's change signs and Y's remain the same. And we've already done this one. Yeah. The X's change, Y is the same, so this is even. So with these examples show you that the only type of equation that can be with a constant, because a constant is an even function, right? So it can only stay with even functions. An even function is if it has an even exponent. If all the terms have even exponents, then it's an even function. If they have even exponents and a constant, it's an even function. Odd functions can only have odd exponents. The exponent here is 1, and that's an odd number. This was an odd function because 3 and 1 are both odd exponents. So a function is even if all exponents are even or you have a constant. It's actually and or. You can have all even exponents and a constant, or just a constant. A function is odd if all exponents are odd and no constant. Because the examples I was going to show for those were going to be things like this. Odd, even, or neither. Look at the exponents. Yeah, but I said to be an odd function, it cannot have a constant. Even all the exponents are even. So this one's neither. Because all the exponents are odd, this is a 1, but it has a constant, so it's neither. Odd, even, or neither. This one's even. Because all the exponents are even integers and you have constant. I mean, even if the constant wasn't there, it'd still be even. Odd, even, or neither. Yes. Because all of the exponents are odd numbers. This is a 1. So since it's odd, what does it tell you? It, it's symmetric about the origin, exactly. So this graph will look like something like that. And if it's even, it's going to be symmetric about the y-axis. Actually, there are a couple more things I want to show you. By looking at these equations, you can tell me a lot more without doing any math. We know in the first one, the y-intercept is 2. Because it's an odd, it's an either function, but because the highest exponent is an odd number, the graph will look something like this. Because the highest exponent here is an even number, the graph will look something like this or like this. We call this end behavior. If you have an odd exponent as the highest exponent, that means both ends point different directions. If you have an even exponent as the highest exponent, then they point the same direction. We call these guys the degree. If the degree is odd, then both ends point opposite directions. We've been doing this all along from chapter 1. What's the degree of this equation? Y equals 3x plus 2. What's the degree of that one? What's the largest exponent on the x? 1. It's an odd number, so the graph, both ends point opposite directions. From the library of functions, for this function, we know it's a parabola. Both ends point the same direction. It's an even degree. which will now talk about what's called reflection. Because remember here, I said it's either going to point up or point down. Reflections. How about the x-axis? And about the y-axis. If it's across the x-axis, that means the y changes from positive to negative or from negative to positive. This tells us the negative sign is outside the function. Now, that's a very broad statement. Again, if you memorize the library of functions, then you know what I'm talking about. There's a difference between this one and that one. What's the difference? The negative out in front. It's outside the function. The function is x squared. The function is x squared. So this graph looks like this. Because it's positive, it goes up. This graph looks like this. It's negative, it goes down. It flips across the x-axis. Now the other one flips across the y-axis. That means the x changes from positive to negative or from negative to positive. The negative sign is inside the function. What's the function here on this example? It's one of those things from the library of function table. Please memorize these things. The function is square root because it can't be x. The function is square root. What does a square root graph look like? And it goes to, yes, it goes to the right only. because the square root, you cannot have a negative number inside there. But what if the x is negative to begin with? Then I got to flip it about the y-axis, because I have to cancel the x values I put in there, have to cancel that negative there. So I can use -4. So I have square root of a -4. These cancel. So it equals 2. So at 4, it equals 2. So if the negative in front of the x happens inside the function, that means you flip it across the y-axis. If the negative happens outside the function, away from the x, then you flip it across the y-axis. It just changes the sign of the answer. This one changes the sign of x. This one changes the sign of the answer. What's that graph going to look like? Like a V? No. I mean, it started off as a V when it was that. But what did I do to it? There's a difference. Inside, outside. If it's outside the function, it flips across which axis? Yeah, originally, this is what the absolute value of x looks like. But when I put a negative in front of it, I change it from a V to an A type picture. It flips across the x-axis because it's outside the function. Now, if it's inside, so the absolute value of x looks like this. If it's inside the function, I flip across the y-axis. It doesn't change it, because if I just rotate it, it's still a V. So reflections have to deal with where the negative sign is. If it's inside the function, it's about the y-axis. If it's outside, it's about the x-axis. What do y'all think? It's a lot of stuff I crammed into your heads. And you have it all right here on the symmetry page. It's all right there. I'll tell you what an even function is, tell you what an odd function is. I am sure they'll tell you what reflections are. On Thursday, we're going to talk about transformations. Transformations, basically, to put it in a nutshell, is you're changing where the origin is. You're changing the shape, the direction, and where the origin is. It's a transformation, metamorphosis, it changes. But we'll do that on Thursday. Okie doke.